Routing Information Protocol version 2 or RIP version 2. Both versions of RIP, which are RIP version 1 and RIP version 2, are distance vector routing protocols that use router hop counts as their metrics. They support a maximum hop count value of 15, and any router farther than 15 hops away is considered to be unreachable. The main enhancement of RIP version 2 over its ancestor is the fact that it first sends the subnet mask with the updates. Hence, it is considered to be a classless routing protocol in the sense that it is able to distinguish among different subnets, which is something that is not found in RIP version 1. Let's go to the main characteristics of RIP version 2. Number 1. It transmits the subnet mask with route updates. Sending the subnet mask along with each route provides the means for supporting classless inter-domain routing or CIDR and also variable length subnet mask or VLSM summarization with small added manual configuration. Number 2. It supports plain text and MD5 authentication. Authentication is applied per RIP interface. You can specify either text or MD5 authentication. This feature is extremely useful when security is of great importance. Number 3 is it uses multicast routing updates. Routing updates are sent using the destination multicast address 224.0.0.9. This behavior reduces network resources due to the fact that these packets can be discarded at either layer 2 or instead of being processed and discarded at the transport layer. And the last characteristic of RIP version 2 is that it uses external route tags. Route tags provide a method of separating internal RIP routes, these routes within the RIP routing domain, and from external RIP routes which may have been imported from an external source such as an exterior gateway protocol. Configuring RIP routing protocol consists of 3 basic steps. First, enabling RIP routing protocol on the router. The command to enable RIP routing protocol is router RIP, so we type router RIP. Second, specifying the RIP version to run. Next, the version command is used to specify when RIP version to use, either 1 or 2. If the version command is omitted, then the router defaults to sending RIP version 1, but can receive both RIP version 1 and RIP version 2. Since our topic is about RIP version 2, so we type version 2. And lastly, configuring the network addresses to be included in routing updates or specifying the interfaces to participate in routing updates. Then we type network. This network command is used to specify the directly connected subnets on the router to be configured and that are intended to be included in the routing updates. After we type the network command, then we will type the directly connected network with this router, this network, and this network. So we type network 10.10.10.0, enter. Network 192.168.0. This is a good time to point out that we still specify classful networks with the network command. According to the class full network specified, the subnets of that network are automatically identified and participate in the routing update. By default, routing updates are summarized at network boundaries. In RIP version 2, this auto-summarization behavior can be turned off using the no auto-summary command. Moreover, manual summarization can be configured on a per interface level. So next we will type no auto summary. There are 3 routers on this network: Stephanie, Shanine, and Reggie. Okay. We try to send packet data from laptop 0 to laptop 2. As we can see, it is failed. Also in PC 4 and laptop 2, and from PC 4 to laptop 0. All of it are failed. This is because the routers have not been configured. Let's see how we can configure RIP version 2 on our small network. First, we're going to configure the router of Stephanie. With this directly connected network to this router. Next will be the router of Shanine. With this network, this and the other one. The last one will be the router of Regian. With this network, Examining the routing table is an easy way to see whether the routing protocol and commands have been properly configured. Let's verify the RIP using the show IP route command. Let's try to check on Stephanie's route. As you can see, the show IP route command verifies the route received by RIP neighbors are installed in a routing table, and they are. In the output indicates RIP routes because this command displays the entire routing table, including directly connected and static routes. The listing of routes with an R code is a quick way to verify that RIP is running on this router. In this routing table, 10.10.10.4 indicates the address of the remote network, and via 10.10.10.2 specifies the address of the next hop router to send traffic to for the remote network. Let's check the other router if there is an R code, which is a RIP route. In Shenin router, there are 3 RIP routes. Then let's check for Regian's router. Okay, there are 4 RIP routes on Regian's router. Now let's try to send packet data for all PCs and laptops. Let's try laptop 0 to PC4 and PC4 to laptop 2 and laptop 0 to laptop 2. As we remember before, we cannot send data of all these devices, and after we configure it using RIP version 2, it can now successfully send data to all these devices.